For the respective contribution of the group members, Luke built all the hardware, Renai worked on the state diagram, and we both worked together on developing the code and doing the hardware and software testing.
For our state machine, our initial state is going to be FM idle. In FM idle, the LED is off and stays off. When we press push button 1, we enter this state. The only way to recover from this state is to press push button 1 again to return to idle. Here the LED blinks every quarter second. When we press push button 2 from FM idle, we enter this state where the LED blinks every half a second, and the only way to recover is to press push button 2. When we press push button 3 from FM idle, we reach this state where the LED blinks every 1 second. The only way to recover into FM idle is to press push button 3. When we press 2 push buttons together, any two, we enter this state where the LED stays on. The only way to recover back into FM idle from this state is to press a singular button, not 2, not 3. When we press 3 push buttons together from FM idle, we enter SM idle, and likewise the other way. And SM idle, the LED is off. When we press PB1, we enter this state where the LED blinks every 5 seconds. The only way to recover is to press PB1. When we press PB2, we enter this state where the LED blinks every 3 seconds. The only way to recover is to press push button 2. Now we demonstrate each state of our state machine. Starting off in slow mode idle, or fast mode idle, we have a blinking light that turns on quarter of a second, off quarter of a second. We return to idle, and we press push button 2, half-second interval. Other push buttons don't do anything until we press PB2 to return to idle. Push button 3 gives us a 1-second interval. Fast mode idle. We can now press 2 buttons together. The LED stays on. We press any individual button for returns, and then push button 1. When we press 2 buttons, we don't return to fast mode idle. Any individual button will. We press 3 buttons. We go to slow mode idle. I push button. 3 buttons. Now we have a 5-second interval. 4 seconds. We also have a 3-second interval. 3 seconds. We also have push button 3 that does nothing in slow mode. We can also return to fast mode. Now, that is our state machine. For the program, we use an 8 megahertz clock. So here is our main where we set some initial config before we get to our state machine. So in our state machine, how this works is that we have a state variable state, and it uses a switch to switch between states. When the program enters a state, it will stay in this state in a while loop until something has happened that will make it exit. That is, the state variable has been changed by some condition. So the program will check its I/O at first, and then it will react accordingly. If it has no reason to switch state, then it will set its config, that is the LED and its timers, before entering idle, where it will stay until a CN flag, triggered by a CN interrupt by the button presses, occurs, in which case it will exit idle, clear the flag, and perform its I/O check. And the structure is repeated across every state. For our other code, we have our timer here. It is a pretty simple timer. It uses a 32-bit TIA timer 2-3, and we just set the prescalers and PR registers accordingly. Our I/O button press, we have a debouncing where the I/O check doesn't exit until all buttons are released, and it will record every button that's been pressed in that interval. Clock change is a provided file, and so is our UART, where we provided some mild modifications for our program, and that's about it.